So good afternoon and welcome back. And my name is Philip Tomsich and I have the pleasure of introducing keynote speaker here today that many of you haven't really seen in this role before. So Andrea Gallo has a storied history. I know his CV very well because I was on the hiring committee at RISC-V International twice for him. First when we hired him as our VP Technology and then as the CEO of RISC-V. But his experience goes back 20, 25, 30 years almost, covering ST microsystems on the engineering side, on the standard side, later on being one of the leaders of Lenaro, and now he's the CEO of RISC-V International. One distinction that we always say is him being Italian, he brings the people together. He bridges the cultures and makes us all talk about what we want to do next. And today he's here with a keynote about the roadmap of RISC-V, what we're going to achieve in 2025, what we've set in motion beyond 2025, and of course how we're going to put some RISC-V chips into space as one of our upcoming achievements. So with that, my pleasure to announce you, Andrea.
Thank you, Philip. And it is 30 years sharp. And this is my second visit to Brazil. First one was, Chiro, was it 15 years? 16 years ago? Yes. So I'm happy to be back and see plenty of friendly faces from Brazil and from China as well. So I'll try and cover some of the points that were already anticipated this morning and that will be covered later today and tomorrow from the perspective of the broader RISC-V picture. So that was the wrong one. Let's see if this one works. So which is the right button to move forward? So RISC-V is the industry standard instruction set architecture that expands opportunity. Let me elaborate a bit more on the industry standard and clarify a little bit. Some mentioned in the previous presentations open source RISC-V, and I would say that is not 100% correct. A standard is a publicly available, think of RISC-V like USB or Wi-Fi. There's a publicly available specifications that describe how to develop products that are compliant to the standard. You can download the USB specifications from usbif.org. Okay, is it better? Okay, so you can download the USB specification from the website, and wherever you are in the world, in Silicon Valley, in Europe, in India, in China, you can develop a USB product, a USB peripheral. The same is for RISC-V. You can download the RISC-V specifications, and you can develop a RISC-V compliant product. The instruction set architecture is the contract between the software and the hardware design. And RISC-V International is the non-profit organization that coordinates the evolution of the specifications. And we introduced a very different model where we release the specifications on our website under the Creative Commons license. So there are no licensing fees, there are no royalties, and everybody in the world, wherever you are, you can design your products. RISC-V International develops the specifications, and then anyone in the ecosystem can develop a RISC-V implementation. Can be an open source implementation as described by Dr. Bao this morning. can be commercial implementations that you can license, or can be implementation by a semiconductor company that go directly in production. RISC-V does not have, RISC-V International does not have one preferred implementation. We foster all implementations of RISC-V without preference. We are poised for a very big 2025. There's a quote by the VDC Research, released last April. RISC-V success has extended beyond embedded to storage, HPC. I would add IoT, AI, automotive, and space to the list. And I would like to share with you a short glimpse of all these verticals that RISC-V is growing into. This is a preview of the report from 2025 from the SHD group that we shared already in October last year from our previous CEO, Calista Redmond. So some of you are familiar. This is still very much up to date. And the prediction from the analyst is that by 2031, RISC-V will ship 20 billion SOCs in 2031, and every SOC will contain multiple RISC-V cores. And in 2024, just to set the scale, just one company, NVIDIA, estimated and publicly disclosed last year that probably in 2024 they shipped 1 billion RISC-V cores just by NVIDIA in their GPUs. As in every GPU, there are between 10 and more than 30 RISC-V cores. The same report by the SHD group predicts that by 2031, RISC-V will be from 26 up to almost 40% market share in all these verticals. And you can see from networking, industrial, data center, automotive, consumer. So let me go into some of the details of some of these verticals and provide some more visibility. Why is there all this interest in RISC-V? Countries are investing in RISC-V because RISC-V enables to drive your tech sovereignty strategy. This was also mentioned by Professor Benini earlier in the interview right before lunch. Countries are investing in RISC-V, and that's also one of the reasons why we are here today, because countries want to accelerate the growth of a local pool of talents, students, experts, investing locally in your countries, building expertise and competence, and incubate technology that then will be transferred from research, from academia to the industry. And this is what is happening here. And that's why I'm so excited to be here today. Multinational companies are investing in RISC-V because thanks to RISC-V, they can embrace new opportunities, new business models, and most of all, they can control their destiny. They can build their roadmap with confidence that they can leverage multiple suppliers and not only one. There's no lock-in. So they can build their own strategic roadmap as a multinational company with all the everything that they owe to their stakeholders and all their engineers and employees. They can build and control their destiny. Academia, that's also the reason why we are here, researchers. It's so easy to start from a RISC-V implementation that's available, like the one presented by Dr. Bao, and grow and build on it, and build innovative research, and then transfer to startups. What is also happening as a trend is that if in the past we were designing general purpose computers and then general purpose system on chip, with RISC-V we are developing workload design silicon. We are analyzing the workloads that we want to run. We are identifying the key functionalities, key performance, key dimensioning factors, and then you are all designing your chips to maximize the performance for those workloads. So it's a strategic change in the game. And so let me spend a few minutes on the industry verticals that we see growing fast, and a few minutes on how we are improving the developer experience for all the developers on RISC-V. So let's start from the industries and the verticals. The first one is automotive. Last March, Infineon announced publicly that their roadmap on automotive is based on RISC-V. And Infineon is investing heavily in RISC-V, together with many other companies, and I can mention Cortus, MIPS, Andis, Sci5, and many others, Codasip in Germany, Nuclei in China. They all have IPs and parts that have already been certified ISO 26262, and some are already being used in production. And so at RISC-V, we started an automotive SIG. This is currently being chaired by Infineon and Tenstorrent, and there are many other companies participating. The goal of a SIG is to bridge the experts on RISC-V and the experts from the automotive domain. Analyze the requirements, be real-time, functional safety, AI, ML, because in a car there's more and more AI. Analyze all those requirements and map them to the technology that is available on RISC-V. And build non-normative educational advocacy papers, best practices, or even align on profiles and define how an ECU for automotive would look like when implemented with RISC-V, so that we align multiple different vendors and bridge the gap with the software vendors. Another case is, well, if you look at a software-defined vehicle architecture, you can have the ECUs, you have the zonal controllers, and you have the central compute. And in each one, you have different needs. You may need a 32-bit controller for the ECUs, but then you need some partitioning and memory protection when you want to run AutoSAR. Or you need AI/ML capabilities in a zonal controller. I see the zonal controller as the edge computing of a car. And you need AI/ML there. So you may need also additional real-time capabilities, and maybe you need to move to a 64-bit. So all these analysis, what is being done in the automotive SIG. Data center, of course, we heard many talks today about data center and RISC-V. I can mention that Rivos and Canonical are working together very closely in having official support for Ubuntu on RISC-V. A few months ago, Canonical disclosed that they are working on plans to officially support the RVA23 profile. And I'll explain the value of the RVA23 profile in a minute. In China, we have many initiatives with Xuan Tier from the DAM Academy, Shang Shan from the BOSC or SpaceMeet, all supporting RISC-V in the data center. And then you have Ventana, Fedora, all supporting RISC-V. And inside RISC-V, we have been working on multiple specifications dedicated to the data center. We ratified the server SoC. We are finalizing the server platform specifications. And the goal is to describe, let's say, build the blueprints for a data center based on RISC-V. And this was also mentioned, I think, in the interview by Luca Benini before lunch, helping the ecosystem with blueprints. Well, the server platform, in a way, is somewhat a starting point for a blueprint, because it defines not only the characteristics of a RISC-V CPU, including also common peripherals like timers, interrupt controllers, IO, MMU, but it also standardizes the boot architecture, the common boot requirements, so that an operating system would boot the same way across all RISC-V server platforms. There was a talk by Fabien Piuzzi from Scaleway, and you can find the description down there, and you can go on the RISC-V website and find the recordings. Scaleway is a pioneer in deploying commercial cloud based on RISC-V. In his talk, he went through all the pain points, all the pain and the problems that they solved. And what he has been through, his journey as a pioneer in data center with RISC-V, matches perfectly with what we're doing with the server platform. And he concluded his talk with a call to action. Join the server platform task group and be part of finalizing the production-grade RISC-V in the data center. AI, RISC-V is ubiquitous in AI. Here there are some news. Of course, the biggest one I mentioned is NVIDIA shipping over 1 billion RISC-V cores just in 2024. And these IPs are used in the Meta AI accelerator. Ahead Computing, the new startup from former Intel executives, raised more than $20 million in their round of investments. Accelera in Europe raised more than 60 million of funding. So everybody's investing in RISC-V for AI, Semidynamics, Ubitum. And in RISC-V, we have the special interest groups dedicated to the AI. We have a double approach. On one side, bottom up, we are looking at the computational needs of AI, identifying new extensions, new instructions that may provide better performance, or new data formats. For example, recently we ratified, well, last year, the bfloat 16 data format, which is very important for AI ML. And on the other side, we're starting from the frameworks, and we're going down from the frameworks down to the hardware, identifying where we can integrate the extensions from RISC-V in AI ML. Space. Philip was mentioning bringing RISC-V in space. Actually, RISC-V already reached the moon with a microchip a few months ago. In April, I was in Sweden at the RISC-V in Space workshop that was organized in Gothenburg, early April. That was organized by Frontgrade and the European Space Agency. And every speaker on stage had their RISC-V project. I counted more than 50 different RISC-V projects in just 2 days, all dedicated to space. And even more fascinating, I've always thought that SaaS for me meant software as a service. Well, in the space world, SaaS means satellite as a service. It means that you have a satellite like a cloud computing, but up in space. And you can rent a computing unit of a satellite, and you can upload your, I don't know if it's a container or what the software delivery mechanism really is, but you can write your software and upload it on a satellite. Imagine the implications in terms of isolation, security, redundancy, reliability. So these were all the topics that were covered in the workshop in Sweden. And we have companies that are investing heavily in space with RISC-V, Frontgrade, Microchip, Sci-5, the agencies, the NASA and the European Space Agency, and many others. So we are launching a space special interest group, similar to the automotive one. Some of these companies that we met in Sweden were asking how to really isolate different software workloads using RISC-V. So they know the requirements, but they don't know how to accomplish it with RISC-V. And we have the experts from the Security Horizontal Committee who know everything about isolating workloads, but they don't know anything at all about space. So space special interest group is where you bring the technical experts and those from the specific domain together. And the HPC is another important area, of course. And in the talk by, before the interview, the last talk by Tanya, she was mentioning investments from the EU. Well, the EU, through the Euro HPC, launched the latest funds again in March with the DARE project, and that is providing 240 million euros to develop RISC-V based supercomputer CPUs. And you see some of the companies that are involved in RISC-V and supercomputers, in addition to the Barcelona Supercomputing Center, OpenChip, and many others. Let me give you now, moving more towards the members and then the developer experience. On the membership, these are the companies that joined RISC-V over the last 6 months, since January. And you can see that it's a mix of different geographies, China, Europe, and you see from AI, autonomous drive, supercomputing, consumer, telecommunication like Vietel, security like Trustonic or OSIX or SCI. So it's a complete spectrum, and every day we receive new membership application forms. And so we need now to continue investing in improving the developer experience, which has been a continuous topic during this morning. And I'm sure later today and tomorrow will be a part of all your conversations and talks. One point that has been raised is the alignment between all the different implementations of RISC-V. And I'll give you some examples of the flexibility. We're saying that RISC-V is modular, and every extension is modular and can be applied on top of the others. So in theory, every company can have a different implementation of RISC-V that is tailored to your specific project. When it's a purely vertically integrated embedded product, then yes, you should do a handcraft, tailor-made implementation. But when you want to run a modern operating system and have an ecosystem of companies in a vertical with multiple silicon suppliers, be it data center or automotive, then you need alignment between all the different players. And this is the concept of a profile. The RVA23 is a profile for an application processor. It mandates the common minimum set of characteristics of a powerful application processor. It was mentioned by the presentation by, I think it was by OpenEuler, supporting vector and the hypervisor. These are the critical additions. And the value of the RVA23 is that operating system companies are now building their operating systems for RVA23. And chip vendors and IP vendors are designing for the RVA23 profile. So this means that there will be binary compatibility for applications and operating systems that are built for RVA23. They will run on every platform, silicon platform built for RVA23. So that's where we are bringing together full alignment. And in addition, we have been helping the developers shipping the latest boards to the key maintainers. Just in 2024, we shipped 280 boards to key developers. Currently, you see that the latest boards we have been shipping are the Banana Pi, the Sci5 P550, and the Milk5. Whenever there are new boards with more powerful chips that become available, we will contact the suppliers and ensure that we can provide boards to some of the key developers. And in addition, we are making some of the boards available remotely through some of the partners from Edinburgh, from Pakistan, from China, and so on. The other important way of learning about RISC-V and engaging and helping the developers, of course, is education. And we have a growing catalog of open, free courses that anyone can apply for. As part of my job interview, as Philip was mentioning, I went through some of these courses because I wanted to prove that I could learn and get up to speed with RISC-V. So I went for the RISC-V fundamentals, and I got the RISC-V Foundational Associate certification. The one I love the most is building a RISC-V CPU core. That drives you from reading the specifications to writing the system Verilog and implementing a very simple core in system Verilog, including writing some of the tests in assembly to verify that your implementation is working as expected. Of course, it's a little toy compared to what you are all already doing and what Dr. Bao presented this morning. This is a little toy. It's a single stage, single pipeline, 32-bit, very simple, one single clock cycle thing. So you can imagine the simplicity. Yet, by developing your RISC-V core, you appreciate the design principles behind the specifications. And I think that every single software engineer who has never written anything in Verilog, never designed anything, should take this course. It will be very beneficial, and it's free. RISE was also mentioned this morning by Luca. RISC-V hardware without software is not worth anything. So RISE is the RISC-V software ecosystem. It's funded by some of the key companies in RISC-V, and they are funding projects to port and optimize tool chains, libraries, compilers, workloads for RISC-V. And together, we invested in upgrading our membership in Yocto. To me, Yocto is critical. Yocto is the most deployed embedded Linux distribution. It's used not only in embedded, edge AI, but it's also automotive, set-top box, smart TVs, infotainment for automotive. So it's very ubiquitous. To me, joining Yocto at the platinum level is a bold statement. It's a bold statement of intention by RISC-V. Joining the Yocto project at the platinum level means that RISC-V will be on par with the other instruction set architectures. The RISC-V will be used in testing, and if any release or any patch breaks on RISC-V, it will be reverted. So once RISC-V is there, that is a very bold message to the ecosystem. And it also means that RISC-V will have a 4-year of long-term support. And this is all part of helping the developers. Having an edge AI and embedded Linux distribution is very important for the developers and the device makers to start developing their products from a consistent baseline. When you receive a developer box, a developer tool developer board from a supplier, you need to rebuild the software baseline, the kernel, the tool chain, the make files, the libraries, and that can take weeks, if not months, before you can start adding your own value on top. So Yocto for me, is a tool to reduce this time from the moment you start working with a supplier to the moment you can start adding value for your own product. As part of the developer experience, important news are Red Hat supporting officially RISC-V with their developer preview. That's another very important step, RISC-V with Red Hat and Sapphire working together. So it's one of the major operating system distributions. And similarly, Canonical is supporting Ubuntu on the RISC-V DC-ROMA laptop, on many boards. We mentioned also with Rivos. So Yocto, RHEL, Ubuntu, OpenEULA this morning, all the major operating system distributions are supporting RISC-V. And that is part, again, of enabling all the developers. Let me spend a few minutes also on the technical side of some of the progress at RISC-V. We said that RISC-V is modular, that is all based around extensions. So we have extensions that add performance, functionality, floating points, vector, these were mentioned already. Then there are non-ISA extensions like interrupt controllers, IOMMU, and so on. And then we combine these extensions into profiles. So a profile for an application processor, a profile for an embedded processor. Now we're working on profiles for microcontrollers. And then I described the idea around the server platform that is, and the call to action from Scaleway. So in a similar way, in the future, we can work on platforms for a mobile and a smartphone, or for automotive, or for an edge AI, and these then would lead to the software integration and product blueprints. We already covered the RVA 23, so I will just move on. Last year, we ratified overall 25 specifications. I'm not going into the details, of course. Some are about improving the performance or monitoring the performance with quality of service and counters. Some are about improving security and resilience. Some are about control flow integrity, ensuring that you are not suffering from cyber attacks and malicious code modifications. And some are improving debugging and trace. All this was done just in 2024. And this year, so far, we have ratified 8 specifications. Again, more about performance, load store pair, the intrinsics for vector, but also, as I mentioned, server SOC, and a set of specifications that improve the performance when invalidating caches or improving debugging and trace. So overall, all the spectrum of the development at RISC-V. For the rest of 2025, this is the list of the top priorities. So vector is done, server SOC is done. We're now working on the server platform that will be hopefully by fall. The others are continuing on security, and we're planning on releasing also application notes on how to implement the best security strategy on RISC-V and Matrix. Matrix is very important. Matrix is important for AI, and it's important for high-performance computing. And today we are having 2 sets of approaches on Matrix. We have vectors. So when you do matrix operations, somehow you look at rows and columns of a matrix, and those are vectors. So we're having 2 approaches on matrix operations. One is reusing the vector extensions, so adding a small overhead on the die size on top of the vector extension that is existing. On the other side, develop a complete new matrix operations unit. And so some members are opting for reusing the vector unit and adding small addition on top because they want to minimize the die size. Others prefer a complete, more powerful matrix unit. So this is an example of the flexibility of RISC-V. You can find your sweet spot for your product. If you're looking for throughput, for performance, latency, die size, and power consumption, you evaluate all the elements for your decision. RISC-V is turning 15, or has just turned 15. So I would like to leave you with the link to this blog post. It's a quite an interesting long article. It's a great write-up. It goes through the story of RISC-V from its inception at UC Berkeley 15 years ago. The key turning points in history when RISC-V was adopted by Western Digital, or when NVIDIA decided to switch to RISC-V, and all the recent events over the years. So I will leave you with this link and invite you to read this paper because it's a very fascinating history. And I wish you an amazing continuation of this first Grow workshop. Thank you.
Questions?
Hello, Andrea. Thanks for the enlightening talk. You told us about many different kinds of applications of RISC-V processors, and they all have something in common, which are they're specialized for either HPC, AI, or cars. Do you see RISC-V penetrating the more wide consumer market, like laptops, desktops, and mobile, perhaps?
Well, we have a developer laptop today. It's the DC Roma laptop. It's targeting developers. I'm coming from the workload optimized silicon. Mm-hmm. So you start by identifying where you add value, where you can provide the best performance, or when you can disrupt the existing environment. I'm sure that from a data center high performance CPU, it will be very easy to move to a workstation or move to a desktop or laptop because you scale down. And the RVA23, the application processor, is the baseline. When you see that RHEL or Ubuntu are running on RISC-V and on the RVA23, then everything is possible.
Okay. Thank you.
Hi, thank you for the nice talk. I would like to try to ask what is missing for the RISC-V to penetrate in the data center market, and why do you think it would be better with the RISC-V in comparison to ARM or other RISCs? Because if you look back to the 20 years, 30 years, the RISC had a difficult path trying to go in this market. And how RISC-V and all of this beautiful ecosystem may take a new path inside this scenario.
We are putting all the elements together. I mentioned all the extensions. I mentioned the operating system distributions. Luca, in his interview, covered the effort of porting all the software packages. I was part of that effort started in 2012, when we started porting all the packages from one ISA to another. And so we know what that means. You start from areas that are easier because the workloads are more controlled. That's why you start from an AI accelerator card, or you start from an HPC supercomputer where a lab controls the complete workload. Those are areas that are faster to get into. And an AI accelerator card like the ones by Accelera or maybe TensorRent on a PCIe, and there are many others. They are easier because you are not bringing the entire workload. The goal is for the developers of cloud applications and cloud services to not even know which platform they are running on. If they don't know that they are running on an ISA or another, it means that you achieve your goal. A friend of mine used to say that it should be boring, because you don't realize the difference. Then it's when you see that it's a fraction of the power or a fraction of the cost, then you realize it. And so in that case, it means that bottom up, we need to port all the software layers that are required to achieve the goal. And that's where RISE or the other efforts are important.
Hi, Andrea. Thank you for the great presentation. I worked before on open standardization efforts with high impact in society. We standardize the digital TV standard in Latin America that now reaches 600 million people. How is the harmonization of the patenting interests? Did RISC-V face any patenting content yet? And how harmonic is the building consensus in the community?
It's a great question. The key is that all our contributions are done by member companies that have signed membership agreements. In the membership agreements, there are specific clauses that ensure that all the members work in full confidence, that there will not be patent issues. Nobody shall contribute anything that discloses a patent. And nobody shall go against the original specifications. The membership rules and the membership agreements are publicly available on the website, so you can look at them. And so it's really, while RISC-V is open and the specifications are public and you can download them freely, if you want to contribute to the specifications, you shall be a member. So you should accept those clauses, which give the confidence to everyone that you can work together without risks. There are clauses that protect from making mistakes with patents and IPs. Yes, it's important.
Any more questions?
Andrea, good to see you. Thank you for your presentation. It's very clear. I'd like to explain more here for this audience about your view for the South America, the Brazil, how you can improve RISC-V in the Latin America, and how the RISC-V could be helping to the locally development and increase the innovation here in the South America. Please.
You are anticipating the questions that and the topics from the panel. That's unfair. Last year, Calista, when she was our CEO, she used to say that RISC-V allows every country to invest locally, and as you are doing here in Brazil, and as other countries are doing. I was in contact with India. We have friends from China here and Europe. The European Union is funding projects locally in Europe. So countries are investing locally to build talents. And RISC-V, as Calista used to say, RISC-V allows all the countries to engage globally in a global ecosystem. And so at RISC-V, we want to promote collaboration and investment in every country across all boundaries. The specifications, that's why I made the example of the USB or the Wi-Fi Alliance. It's the same. Specifications, public specifications across all boundaries.
More questions?
My question is about RISC-V Hardware Performance Monitor, and I've had a bunch of RISC-V's SBCs along the years, and I had one problem with them that still exists. I have a little difficulty to make any kind of benchmark with them, because most vendor images doesn't come with a working build of perf, Linux perf. So in Linux environment, I can't make benchmarking most of the SBCs I have, because I have to build an entire new image just to make a benchmark and compare a score with another SBC. So there's an effort from RISC-V Foundation for testing each SBC that launches, each SOC, just to measure how much each core improves from one to another.
No. No, because our role is to be fair to all the members. So our role is not to compare one implementation versus another and show that one may be, that we may have a preference for one or another. Our role is to be fair to all the members who are participating in RISC-V. So we are not running benchmarks. We are not showing performance side by side by different implementations of different RISC-V members. This is a very important policy. Of course, nothing prevents third parties to do that. And for example, there's an article, I can share the link. There's an article by Professor Nick Brown from EPCC in Edinburgh. He looked at the chip by TensorTorrent, the AI accelerator by TensorTorrent. He worked with TensorTorrent, so it's an official article. It's endorsed, and describes all the architecture, and then runs benchmarks, and looks at the performance, and compares with other ISAs. So I invite you to look for that article, because the performance is really impressive.
If you don't have any more questions, I think we can thank the speaker again. Thank you very much for accepting the invitation to be at
Thank you for having me.
Thank you.
Hi everyone. We have a break scheduled, but since we're running a little late, let's try to move on to the next session. We'll just take a couple of minutes to set up, and then we'll get started, okay? Thank you.